Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to use conditional statements in C++. We'll start by creating a new project. We're going to create a Visual C++ empty project and call it conditional demo. I'm going to place it on the desktop and click OK. Once we have our project, I'm going to set a few properties on the project. In the linker under system, I'm going to change subsystem to console. This will keep our console window from closing when we run it. Next, we're going to add a new item. And we'll add a CPP file and call it conditional demo. Once our new CPP file opens up, we'll write the standard things that we need on a C++ program. We'll include IOStream so we can do output, and we'll use the standard namespace. After my comment header, I'm going to start the main function. This is the function that's executed first by the operating system. And the first thing we're going to demonstrate is the if-then statement. So I'm going to declare a string called user input. And I'm going to use the getLine method to fill user input with A, B, or C from the user. Notice that getLine gives me an error. That's because if we use getLine, we also need to include another library, and I'm going to include the string library. As soon as I include the string library, we see that the red underline under getLine goes away. So the if-then statement, we type an if, and then in parentheses we place a statement that should evaluate to a Boolean. So I'm going to check user input and see if it is equal to the string A. And if it is, I'm going to output a message that says you entered A. Now, so if we run that, what we see is we get our prompt to enter A, B, or C, and if I enter A, it says I entered A. So it actually executes this code. Hitting Control F5 again, I'll run it again, and this time I'll put in B, and we see that it doesn't execute this line. And the reason is that it checked this evaluation statement. Since I entered B, B is not A, and therefore it won't execute what's in between the braces. So that's the basic structure of an if-then statement. We can also use an else statement, and we can enter something along these lines. And if I compile and run that, again, if I enter A, it will run the first part under the if. But if I enter anything other than A, it will forego the first option and run the else. So that's the general structure of an if-else. The other thing we can do is we can say else, and we can chain our if-then-else statements. So I can say if user input equals B, I can have a statement that says you entered B, and then I can add another one. If they say enter C, then I'll tell them that they entered C. And we can finish up with a final else statement, and I can tell them if they didn't enter any of that, I can put in you did not enter A, B, or C, and tell them that that was an error. So you can chain multiple if-then statements together, and the way this works is it'll look at the first option, and if that's true, it'll execute this first one, and it won't check anything else. Then it'll check, but if it isn't true, then it'll check the second condition, and if that one's true, it'll execute this one, but it won't execute anything else. And again, if it doesn't meet that second condition, then it'll check the third condition, and at the very end, it'll always execute this else if it didn't meet any of these previous conditions. So if I compile that, enter C, it skipped through A, skipped through B because it didn't meet those conditions, and then it saw it was C, and so entered C, and it didn't do the else because it met the second condition here. So the strength of the else if statement is that I can very efficiently go through this list and find the option that was selected and then perform an action based on that option. Now for efficiency, it makes sense that the most likely option should probably go at the top, and the least likely option should go at the bottom. We can also nest if-then statements within each other. So for example, if I look at option B, I could actually check, well first let's create something that we need to switch on. So I'm going to add another string called yn input. And then I'm going to tell the user please enter y or n. And get that input into y input. And then within b, I'm going to check for that. So if I put and note, these checks are case sensitive, so you want your instructions to match the case. So if they do match, I'm going to, so if the user did put in y, it's going to tell them you entered b and y. Else, it's going to look to see if y input equals no. And finally, if it doesn't meet either of those conditions, I'm going to basically tell them they have an error. So what we can see is we have a nested if statement. So it'll go through these if statements, and then within this if statement, if it is a b, it'll then do another check to see if it's a y or an n, and then display the appropriate message. So when I run this, it first asks me to enter a value. If I enter b, it'll always ask me if y or n. I'll put in y. It tells me I entered b and y. So it came down through here. It wasn't a, skip that. Else if input user equals b, it was b, so then it does the next if statement. If y and input equals y, and the input was y, so it executes this cout statement. Skips these else's because it already found this statement in here, and then comes back out here and skips all these other else's because it had met the b condition. If I run it again and I enter a and then I enter n, notice that it runs this if statement here, but because there isn't this nested if then else statement that is in b, there isn't a similar one in a, it actually doesn't do this y and n part. It just does the a part and then skips everything else. So we don't see, it only says you entered a. It doesn't say you entered a and y. So the next thing we can do is I'm going to delete this code to demonstrate something else. And we're going to just demonstrate the ternary operator. The ternary operator is basically a shorter way of doing an if-then statement. So this program is going to figure out whether or not the air conditioner is on. And to do that, since we don't have direct hookup between the computer and the air conditioner, we're just going to ask the user to tell us what the temperature is. So once we get the temperature in from the user, we're going to assign a value, the appropriate value to air conditioner. And the way we're going to do that is we're going to check temperature and see if it's greater than 80. So everything inside this if statement, within these parentheses, just needs a Boolean statement that evaluates to true or false. So the double equal signs, for example, would check to see if they're equal. Realize that if I just put one equal sign, that will not work. That's actually the assignment operator, and that would sign 80 into temperature, and that would not do what you want. In fact, it might even run, but this is not, and it would put 80 in the temperature, and you would get some strange results. So what you really want to do is you either, if you want to check for equality, use the double equals. In this case, we want to see if it's greater than 80. We could also say, is it greater than or equal to 80, or less than or equal to 80? So any of those Boolean operations can work here as long as the operation result returns true or false. Next, if it's true, if it's greater than or equal to 80, we're going to set the air conditioner equal to the string on. If it isn't true, we're going to set air conditioner to equal to off. Notice that capitalization is important. And then we're going to use that string to make a nice looking output. The air conditioner is, and we'll just also display air conditioner. And we'll end line. So when we concatenate this, it'll tell us if it's on or off. So I hit Control F5 to run it, and it says please enter the temperature. And if I type in 90, it says the air conditioner is on. If I run it again and I put 70, it tells me the air conditioner is off. And the way it's doing it is it's evaluating this Boolean statement here. And if it's true, it does the first part between braces, and otherwise it'll execute whatever is in the else statement. But let's say we wanted to write this in a little more succinct manner. Well, we can, and the way we do that is as follows. And this is the ternary operator. I just say air conditioner is equal to, and I put in the Boolean statement that I want to check, temperature greater than 80, and then a question mark, and then I put the result that I want if it's true, on, and the result I want if it's false, off. This single line here does everything that this line did, and in fact I'm going to comment that out. And so this code here is not being executed anymore. Only this ternary operator is being executed. And the ternary operator is this question mark. And basically we put a true or false statement here, a Boolean statement here that gets evaluated, and if it's true, it'll do the first part. If it's false, it'll do the second part that's after this colon. So that's the structure of a ternary operator. The condition, result if true, result if false. And again, it works the same way. If I put in 90, it says on. If I put 70, which is less than 80, it says off. The next decision control statement that we're going to use is the switch statement. So I'm going to delete that work that we did so far, and we're going to create a char that will record user input and a string and then we're going to display instructions to the user. And we're going to output that to the user input. Now the reason why we're using char is because a switch statement only works with an integer or a char. And we say that we're switching on user input. And we write case statements. So if it's A, we tell the user that they entered A. And then we have to put a break statement, and then we put case B, and again a break statement. And then we're going to have a default condition. A default condition is kind of like that final else, and what it will execute if the other ones did not execute. So the way this works is this. The user will enter A, B, or C. Then the switch statement will look at that character and will look and see if it's case A or B or C. And if it is that case, then it'll output the appropriate output that it'll execute the statement that we provided, which in this case is a C out statement. And then this break will cause it to break and go to the bottom of the switch statement. In fact, this break statement will work in a lot of statements in order to cause it to break out of a series of evaluations like this. If we didn't have the break statement, it would look at A and then it would actually continue checking all the cases. And since once we find one, we don't want it to check for B or C, we need to have these break statements. So hit Control F5, say yes when it asks for a build, and again we see, do we want A, B, or C? If I type in B, it says I entered B. So it skipped A, ran this one, when I saw it was B, and then broke out of that and went to the end. Running it again, if I put something that's none of those, it tells me that it didn't execute it. So what it did is it checked for A, then checked for B, checked for C. Since it wasn't any of those, it ran the default and gave me the error. So that shows how we can use if-then statements. We can use if-then with else's. We can also chain multiple else-if statements together, and we can then also use the ternary operator, which is a shortened version of an if-then statement. We can also use a switch statement to switch on either an integer or a char. That completes my demonstration. Thank you very much.